All right, guys. So today we're going to be learning about systems of equations and real-world applications. So before we went on Thanksgiving break, we were learning about systems of equations, and we learned how to solve them by graphing, substitution, and elimination. So today we're going to apply what we learned previously, and now we're going to be solving word problems using systems of equations. And when we're solving word problems using systems of equations, it's important to ask, what are the two unknowns? Okay, asking this question helps us define our variables. Okay, our variables, which we usually use X or Y. So we're going to solve the following word problems by first defining our variables, second, creating a system of equations, and third, solving the system. So let's look at this first problem here. It says Jack has $140 and is going to start saving $20 per week. Sally has $20 and is going to start saving $40 per week. How many weeks, that's an unknown, will it take for them to save the same amount? The same amount is the other unknown. So how much money will they both have when they have the same amount? So that means that our X is going to be the number of weeks. And our Y is going to be the total amount. Okay, now that we've defined our variables, now we need to write a system using the information that they gave us in the word problem. So let's look at this again. It says Jack has $140. So he has 140. So I'm going to write 140. And is going to start saving $20 per week. So he's adding 20x. X because that is the number of weeks. So he adds 20 per week. All right. Sally has $20. So Sally has $20 and is going to start saving $40 per week. Okay. And it's asking how many weeks. So if this is telling us their total amount, so Y is equal and Y is equal, because that would find us the total amount after a certain number of weeks, we can use this information to find out how many weeks it's going to take for them to have the same amount. So remember, when both equations are set equal to the same variable, set them equal to each other to solve, because we have a Y equals 140 plus 20x. And if Y equals 140 plus 20x, we can plug that in for the Y down here. So all we're doing is setting them equal to each other. So we're going to have 140 plus 20x equals 20 plus 40x. Now all we have to do is solve this equation for x, and then we can find our y. So to do this, I'm going to subtract 20 from both sides. And then I get 120 plus 20x equals 40x, because these cancel out. Then I'm going to subtract 20x from both sides. And those cancel out, and I get 120 equals 20x. Then when I divide by 20 on both sides, I find that x is equal to 6. Again, 6 is the number of weeks. In 6 weeks, they will both have, well, I don't know how much money they're going to have yet. So I have to take that 6 and plug it in for my x to find my y. So I'm going to plug that into my second equation. Y equals 20 plus 40 multiplied by 6, because that's the number of weeks. 40 times 6 is 240 plus 20, and that is equal to my y. So y is equal to 260. Okay? So now we found the answer would be 6 weeks, and the total amount that they're going to have is going to be $260. Now, I said we can solve the systems of equations by either doing it algebraically, and this example is kind of substitution. It's definitely not elimination. So we use substitution here. And now we're also going to solve it graphically, because this equation came in y equals mx plus b form. So it was really easy if we just use that same method to graph it and find where the points intersect. So my equations didn't change, so I have y equals, and I'm going to put this in mx plus b form. So I'm going to have y equals 20x plus 140. And I'm also going to have y equals 40x plus 20. So if you remember correctly, our constants are our y-intercepts. And our y-intercept is right here on our y-axis. So that's where I'm going to start. Okay? So y equals 20x plus 140. So I'm going to start at 140 on the y-axis, which is everything goes up by 2. So I'm at 100, 120, 140, and I put my point. And then my slope here is 20x, or 20 over 1. So since these markings are done by 20s, I go up 20 and over 1, and I can put a point. Up 20 and over 1, and I can put a point. I can go up 20 and over 1, and you get the idea. That is my slope of 20 over 1. So I can draw my line. Okay? And I'm going to go ahead and highlight that in pink, because that is our first equation. And now we can go ahead and graph our second equation, which is y equals 40x plus 20. So this 20 here is my y-intercept. So I'm going to go up here to the 20 and mark the point. And then my slope here is 40x. So I'm going to go up 40, 20, 40, and then go over 1. And I put a point. Go up 2, 4, so 40 over 1. Put a point. 2, 4, and over 1. And put a point. 2, 4, and over 1. Then put a point. And the only reason why I'm going to keep going is because I want you to see where they're going to intersect. So 2, 4, and over 1. 2, 4, and over 1. And finally, we've met where they are going to intersect. We've found that point. Okay. And if I follow where that line is intersecting, I can find that my y is equal to 246, so 260. And my x is equal to 6. So in 6 weeks, they will both have $260. That is the same thing that we found when we solved the system using substitution, and that will always be the case. No matter which method you use, you should get the same answers. Okay? So with solving systems of equations, it's important to remember that the trickiest part about solving these types of word problems is going to be creating the system. So I first want us to practice creating the system. So first we need to identify the x and y, the unknowns, and then we're going to write the systems. And for these examples, we're not even solving them right now. We are just going to identify the variables and then write the systems. So I have $6.25 from just nickels and quarters. Okay, nickels and quarters. If I have 37 coins altogether, how many do I have of each? Well, this is a really easy thing to write my variables for because I'm looking for how many nickels I have, so I can label that for my x, nickels, and my y in this scenario will be my quarters. Okay, now that I've identified my variables, it's important to then write my systems of equations. So this says I have $6.25 from just nickels and quarters. So how much is a nickel worth? Well, a nickel is worth 0.05, so 5 cents. Okay. So that's going to be my 0.05x plus 0.25y. So here's my x and here is my y, and they are going to equal $6.25. Okay, so I have my x and I have my y, and they're going to be equal to $6.25. It also says that I have 37 coins altogether. So that means that my x plus my y is equal to 37. So my nickels combined with my quarters is going to be equal to 37. There you have it. I wrote two equations based on the word problem, and now I have a system of equations. So let's practice this one more time. It says in the bike section of a store, there are bicycles and tricycles. So we have bicycles and tricycles. Jim counted 23 bicycles and tricycles altogether. He also counted 57 wheels altogether. So how many, that's our unknown, how many bicycles and how many tricycles are there? So my X I'm going to label as my bicycles. My Y I'm going to label as my tricycles. And now I need to write my systems so I can solve it if I wanted to in the future. So first I have 23 total bicycles and tricycles all together. Okay, so he has 23 all together. So that means my X plus my Y is equal to 23. Okay, I can also write, says in the bike, he also counted 57 wheels altogether. Well, how many wheels come on a bicycle? 2, right? So 2x, because there's 2 wheels per bicycle. And how many wheels come on a tricycle? Well, tri means 3. So 2x plus 3y is going to equal 57 because that's how many wheels there are altogether. So now I used my information based on the bicycle and the tricycle to write my systems. And I just realized as I was highlighting that I highlighted the information incorrectly on the previous problem. So I'm going to fix that before I move on. All fixed. So it says Josh rents a car for $80 per day plus a $100 fee. Rachel rents a car for $50 per day plus a $190 fee. How many days, it says how many days, so that's an unknown, must they rent their cars to pay the same amount? Again, we're looking for an amount, total amount. So X here is going to be my days, and the Y here will be the total amount. Okay, very similar to the word problem that we did at the beginning. We have our number of days instead of weeks and our total amount. Okay, so it says Josh rents a car for $80 per day plus a $100 fee. So my first equation is going to be Y, because that's the total amount, will equal 80x, because that's the cost per day, plus the $100 fee. No variable with that 100, okay? That's our constant. And our Y is just our total cost, okay? So Rachel rents a car for $50 per day plus a $190 fee. So Rachel's total cost will be 50x, because it's $50 per day, plus the $190 fee. Now that I've written the systems, you can use that systems to solve it. But I just wanted to go over examples on how to identify your variables, to label your variables, and then to write a systems of equations. So now we're going to work on 3 practice problems. Okay, and you can solve them either using substitution, elimination, or graphing. Okay, so Michelle makes $30 per hour as a math tutor and $10 at a restaurant. Last week, she worked 3 jobs, 3 times as many hours at the restaurant as she did tutoring, and earned $600 total. So how many hours did she work at each job? Okay, so our unknowns will be how many hours she worked at each job. So first we're going to look at her math tutor, and that will be the X, and then the restaurant will be the Y. So Michelle makes $30 per hour as a math tutor. Again, the math tutor will be my X variable, and the Y will be when she works at the restaurant. So now I need to write my systems of equations. So first, what I'm going to look at is, it says Michelle makes $30 per hour as a math tutor. So 30x, right? Because that's when she's a math tutor. And $10 at a restaurant. So 30x plus 10y. And she made a total of $600. Okay, the $600 is where I got that from. So we had 30x plus 10y equals 600. It says last week she worked 3 times as many hours at the restaurant as she did tutoring. So that means that her y, her restaurant hours, is going to equal 3 times x. Okay? So that one's a little bit tricky because it says y, she worked 3 times as many hours at the restaurant as she did tutoring. So that means 3 times x, meaning her math tutor hours, was equal to her total hours at the restaurant. So we have y equals 3x. So what we can do to solve this is because we have a y equals a 3x, we can just plug in that value for the y into that first equation. Okay, so instead of having 30x plus 10y equals 600, we can rewrite this as 30x plus 10 multiplied by 3x equals 600. So now we just need to simplify it and solve for x. So I'm going to multiply this 10 times the 3x, and I'm going to get 30x. And I still have this 30x plus 30x is equal to 600. Well, 30x plus 30x is just 60x, and that is equal to 600. Then I need to divide by 60 and divide by 60, and I get x is equal to 10. So that's, if my x is equal to 10, that means that's how many hours she tutored. So she tutored for 10 hours. Okay, now can I find the y? Well, yeah, I just have to plug in that value of the 10 into one of my equations, which I'll probably use the second equation here. So, oops, y equals 3 multiplied by 10, and that 10 just came from the x that I found previously. So y is equal to 30. And so that's how many restaurant hours she worked, was 30. Now I said we can also solve this graphically. So to solve this graphically, we need to take this first equation here and rewrite it in y equals mx plus b form. Y equals mx plus b form. Remember, our slope-intercept form. So to do that, I need to rewrite this equation. So my first step is going to be to subtract 30x from both sides. So I get 10y is equal to a negative 30x plus 600. And then I need to divide by 10 so that I have a y equals. So then I'm going to get y equals a negative 3x plus 60. Now that I have that equation, I can use that equation for number 1 for me to graph, for my first line to graph, and then I can use this second equation, which I already had, y equals 3x, to graph my other line. Okay, so to do that, I'm going to first start with my y equals 3x. Okay, and I'm going to start with that one because I don't have a y-intercept, and when I don't have a y-intercept, that means I'm starting at the origin, which is right here where my x and y intersect. And as just a reminder, this is my x-axis, so these are my x values. These are my tutor hours. Okay, And this here is my y-axis. These are my restaurant hours, okay? Those are my restaurant hours. So back to graphing. I'm going to start at my origin where it says 0, 0, and then I'm going to look at my slope. And my slope here is 3. So that means 3 over 1. So I can do any variation of 3 over 1. And since my coordinates are going up by 10, the easiest thing for me to do is going to be to go up to 30, 10, 20, 30, and over 1 to 10, because 30 divided by 10 is still equal to 3 over 1. So I'm going to go up 1, 2, 3, and over 1 again, and I can now graph my line. Okay, now that I've graphed that first line, now I can go ahead and graph the second line, which is y equals negative 3x plus 60. This 60 here is my y-intercept. So that's right here on my graph. It's positive 60. And now my slope is a negative 3. So I'm going to go down 30, 10, 20, 30, and over 1. 10, 20, 30, and over 1. And I see that my points intersect right here, where my y is equal to 30 and my x is equal to 10. And it's the same answer where she tutored for 10 hours, which was my x, and she worked at the restaurant for 30 hours, which was my y. So whether I solved it graphically, using substitution, or if you had changed it and solved with elimination, all the methods would have worked and resulted in the same answer. Okay, we have 2 more practice problems to do. I'm going to do those in a separate video.